So I was talking about displacement vectors and how to add these displacement vectors. Suppose you start from your house and go to your friend's house. This is your friend's house. And from your friend's house, you go to the market. All right. Now, what is your total displacement? How do you find the total displacement? First of all, what do I mean by total displacement? So, what I mean by total displacement is I just join the initial position to the final position. Okay, this is what I mean by displacement. Now, why is this an important quantity? We'll see. Now, right now it doesn't really make sense. Why do I care about what is the total displacement? Right? Why do I define things like this? Right now it might not make sense, but it will make sense soon enough. All right. So this is my first displacement A, and from the friend's house you are going to market. So let's call this as the displacement B. All right. Now, what is the total displacement? So I've defined the displacement to be the initial final position minus initial position, isn't it? So you basically join the initial position, your initial position, to your final position. So you were over here, now you have ended up at the market. So we call that as the result of the two displacements. So first displacement A and the second displacement B result in this particular displacement, which I call as A plus B. I write it as A plus B. A plus means the result. What is the net effect of two displacements? All right. I think in the previous class we have seen that there are many quantities that add up like this, isn't it? What was the quantity that we described? What was the quantity that added up just like this triangular law, according to the triangular law? Sandra, your mic is off. I can see your lip movement. Yes.
So vector quantities?
Yeah, vector quantities are basically these quantities that add up like according to this law, isn't it? Displacement is a vector, that's why it adds up like this, isn't it? What are the other quantities that add up like that? I think I'd given this example where, what did we have? We had a pipe, an invisible pipe at that, and inside that pipe there was a marble rolling, isn't it? Right? And then we saw that this thing called as velocity, which is displacement by time, has to be added according to the triangular law. The same law as before. This is what we had seen, isn't it? Then I say that whatever adds up like this, whichever quantity adds up like this is a vector quantity. Look where I began from. I began from saying that vectors are quantities that have magnitude and direction. That was my starting point, isn't it? After I introduced the triangular law of vector addition, now it seems like I can say what are vector quantities in terms of this addition. Whichever quantity agrees with this kind of addition property, we can call it as a vector quantity. Okay. What else adds up like this, Sarvesh? What else adds up like this? We were trying to pull people, right? What did we?
Force?
Forces, yes. Forces are vector quantities. Right? So if you try to pull a boat in water, one in that direction, right? And there is one more rope pulling in this direction. So which way does the boat go? Which way does the boat go? How did we add this?
So the drag's like between the both.
Between the boat, isn't it? But if I call this as force A and this has the force B, I've used the triangular law, isn't it? How do you use the triangular law over here? I've told you that you can move vectors. If you move vectors, you do not change their values, remember? So what I'm doing is I'm moving this vector from this location to that location. Why do I do that? Because to add vectors, see, I have to place them in the form of a triangle. Look at that. The tail of the second vector has to be at the head of the first vector. Tail of the second vector has to be at the head of the first vector. Then what do? Then you just join the tail of the first vector to the head of the second vector. Okay, this I call as the result of the two forces A and B. Like you predicted, Sarvesh, we are going right in the middle, isn't it? We are going in the middle. So forces add up like this. Forces add up like the triangular law of vector addition, isn't it? So we can call forces as vectors. Anything else you can think of? Anything else that adds up like this?
Velocity?
Velocity we discussed, right? Velocities, yes. Velocities do add up like that. So what do I mean by velocities add up like triangular law? So let me give another example instead of that pipe and marble example, something that you can imagine. So let's say we have a river which flows in that direction. Can you imagine that river water is flowing in that direction? Okay. And what you do is you take your boat, if you have one, okay, and you try to go from this bank, this shore. Do you call it shore or bank? Yeah. From this end to the other end. Okay. You're going that way. What do you imagine would happen to the boat? River water is flowing like this. You are trying to go that way. What do you think happens?
It depends on the force of the river. Like if it is much, then it'll go the diagonal way. But if it is very low, then I think you can just go in a straight line.
No. Whether it is small, whether the velocity is small or large, it will always go along the diagonal, isn't it? Your intuition is correct, Sarvesh. So if the velocity is small, and how do I do that? How do I write that?
When
With
the
a small
force decreases.
Not force, velocity. I'm talking about velocity vectors. Velocity vectors. If the velocity is small, you indicate that the size of the velocity with the smaller arrow. The size of the arrows indicate the magnitude of the vector, isn't it? So if the velocity is small, then you write it with the small vector like that. Then if the boat velocity, look at that, this is the boat velocity, isn't it? You're going in that direction, so you end up going like this. See, diagonal. But if the river velocity is larger and your boat velocity is not large enough, you would end up going more along the river direction than along the direction the boat is trying to take. Correct? Makes sense? Now, how does the boat look like for an for a person on the ground over here? If you are standing over here, how does the boat appear to be moving? So you are trying to move to the other end, right? You are trying to move to the other end, but the river takes you to the right. So it appears that you are going to the other end, but the river takes it to the right like that. Can you imagine that? You kind of drift like this, isn't it? So we say velocities add up like vectors, isn't it? Add up according to the triangular law. This will be one more example. We'll be solving these kind of problems in the next class. Okay. Right now we are just doing algebra. We are just learning how to add vectors, how to subtract vectors, and all those things. Real world problems, we'll see how to apply this concept of vectors. Okay. So all this we had done in the previous class, I suppose. Have you done this problem? Add the given two vectors.
Yes, sir.
Yeah. Okay. Yeah, we have done this, right? What did we do over here? How did we add these two vectors? A
The
plus.
tail of B vector near the tip of A, and then
Yeah, that's the rule, isn't it? So get the tail of the B vector to the head of the A vector. So this is, yeah, I'm just copying this vector over here. Sorry, I've copied it wrong, right? Yeah, this would be proper. This vector is basically 3 steps to the right, 1 step downward. That's what I'm trying to do. 3 steps to the right, 1 step downward. This is B vector. So you can form a parallelogram over here. Look at that. Why the parallelogram? Because that's when you know the vectors are equal, isn't it? Because in a parallelogram, the opposite sides are equal and parallel. Yeah. Okay. Now you just add according to the triangular law. This is the sum. And I think I told you to verify whether A plus B is equal to B plus A, isn't it? I remember now. So I think you must have observed that A plus B and B plus A are same things, isn't it? B plus A would be copy the A vector. This is A vector. See, one step to the right, three steps upward. So from here, one step to the right, three steps upward. This is A vector. What is B vector plus A vector? You add the tail of B vector to the head of A vector. So this is B plus A. Agreed? According to the rule. Can you see that A plus B and B plus A are the same thing? It's a neat diagram. Look at that. You get a parallelogram, isn't it? See, here's your A plus B and B plus A are same thing.
Excuse me, sir.
Yes, Sarvesh.
So how do we find the value of A plus B vector?
What do you mean by value? Do you mean the length of the vector?
Like here we wrote A vector as 1 by 3, like 1, 3 something.
Not 1 by 3. A vector is 1, 3. 1, comma 3.
Yes, sir. So how do we find out about like the A plus B vector?
Do you mean, one second? Don't understand your question actually. Do you mean A vector is 1, 3? This is the representation of A vector, correct? And what would be the representation of B vector?
Yes, sir. Like how do we find out?
Okay. So B vector is 3, negative 1, correct? So one thing is you can just observe this picture. You can do this problem geometrically. Just observe what's happening over here. So A vector is basically A vector as A plus B vector. Sorry, I'm looking at A plus B vector. A plus B vector you basically obtain by walking 4 steps to the right and 2 steps up, isn't it? See, 4 steps to the right and 2 steps up. I can say that A plus B is equal to 4 steps to the right and 2 steps upward, correct? Or I can do this algebraically. I can just add these things. Look at that. A plus B, what is A? A is 1, 3 plus 3 minus 1. I told you this, right? So you just add the components. Look at that. 1 plus 3 is 4 and 3 plus minus 1 is 2. This is not a separate rule. This I have obtained by observing what is happening geometrically. I observe first what's happening, then I write down the rules. Okay, how to add vectors and all these things. This rule will actually make more sense when we go to the real world problems. Why is it like that? Okay. Right now, all I'm saying is just observe the picture. This is what it is. Okay. This I'm sure we have not done, right? Add two vectors. How do we add these two vectors? You can think of these vectors as forces. Forces on the same body, by the way. You can't have forces on different bodies and add them. That doesn't make sense. Force on Sarvesh plus force on Avni, what is that equal to? If we add them, what do we get? Doesn't make sense, isn't it? We can add all the forces on Sarvesh, and that you'll get a total force on Sarvesh. Just like adding the velocity of one car in New York and one car in Mangalore doesn't make sense. What does that give? Meaningless, isn't it? Nidhishri, what's the representation of A vector? How would you represent A vector?
So 3 units to the west and 3 units to the north.
Yeah, 3 units to the west and 3 units to the north. Isn't? How would you write that actually? Avni, yes. Sorry, I did not see your answer. How would you write that? You are right, Nidhishri. You have put it in the best way possible actually. 3 units to the west and 3 units to the north. In numerical form, how would you write that?
3,3.
Is it 3, 3? One small correction. It is negative 3, 3.
Yes.
Is that okay? Okay, negative 3 and 3. Because we have agreed, right? That to agree to call this as the positive direction for now, and this as the positive direction in the vertical direction, isn't it? That's the positives. It's not necessary that we have to call those as the positives, but if you don't do that, then we'll run into confusion. So A vector is negative 3, 3. And B vector, we have to add these two vectors. B vector is 3, 2. Agreed? So when you add these two vectors, A plus B, you'll find that negative 3 plus 3 is 0 and 3 plus 2 is 5. So I'm expecting an answer. I'm expecting an answer that has no x component, but only the y component, isn't it? That's what I'm expecting from my algebra over here. Let's draw that out and see if we get the same answer or not. Okay, so let me try that out. So B vector, let me copy that over here. So B vector is 3 steps to the right and 2 steps up. So let me do that over here. So from here, 3 steps to the right and 2 steps up. So this is B vector. You can just verify if it's correct or wrong by imagining whether it's possible to draw parallelogram. Yes, if you can draw a parallelogram with the B vectors, then yes, it's correct. I've copied it correctly. Right now, adding A plus B. Join the tail of the A vector to the head of the B vector. This is A plus B. And A plus B is 0, 5, isn't it? Look at that. Any doubts over here? Any sort of doubts? Yeah, this is what it's supposed to look like. Yeah, it does, isn't it? Okay, what about A minus B? How do we do A minus B? We have talked about negative vectors, if you recall. This is all about recalling whatever we had in the previous class. What is negative B? Negative of a vector. What did that mean? Nidhishri, can you recall? What is the negative of a vector?
I'm not sure, sir.
What does your instinct say? Negative vector. This is a vector. If this points in the direction of a vector, what does negative a vector mean to? What is the gut say? This is a vector. Negative a vector would be what? Anybody can take this question. Sandra, yes, here, right here. This is a vector. What is negative a vector? Neha, can you take that question? Like, what is the negative a vector?
Is it the exact opposite?
Yes. So if this is a vector, negative a vector would be this, isn't it? That's how we define negative vectors. They are just opposite in direction. All right. Magnitude is same. All right. So here I see that I've got a minus b. Look at that. I've got a minus b there, isn't it? A minus b. See, I do not know how to take a difference of vectors. I know only how to add vectors, isn't it? How do you add vectors? According to the triangular law. Now here I'm asked to subtract two vectors, a minus b. How would I do that? Do I know any kind of trick? Can I turn this subtraction into an addition, basically? Can I turn this subtraction into addition? Because I
Sure.
know, yeah. Yes, Sarvesh.
Sir, actually, there's negative b, right? So we can make it positive by b by making it completely opposite side, and then
Okay.
writing the a plus like a vector plus b vector.
Yeah, correct. Yes, very good. So what we are doing is we are going to write this a vector plus. When I say plus, the vector addition, a plus minus b vector. You see, they are the same thing, right? I'm writing a minus b as a plus minus b vector. But what is minus b vector? Minus b vector is the b vector, exactly the b vector, but in the opposite direction. So let's do that. So b vector is, what is b vector? I cannot see properly what it is, but it looks like 1, 3, isn't it? It looks like 1, 3. See, it looks like 1, 3, I said. So let me copy that over here. So just flipping the b vector now. So I have to come till here, correct? Is it correct? Just let me know. Size has to be same, direction has to be exactly opposite. Is it right? So this is negative b vector. And now what are we going to do? We are going to add a and negative b vector. We are going to add those two arrows. Okay. So how to add these two arrows? First, you move the negative b vector. Move the negative b vector from here to here. Okay, that's the rule, isn't it? So that is, this is the negative b vector, and join the tail of the a vector to the head of the negative b vector. This is A plus minus B, or which is nothing but A minus B. Okay, values are not important right now. We'll see what to do with the values. But did you any questions over here, Sarvesh? Any
So
questions?
why do we do that? Like, how do we know it's right and why?
Very good. How do I know it's correct? That's the first question that we need to ask now. How do I know it's correct? Because what I've done is I basically did a mathematical trick there, isn't it? I simply wrote, I relied on the intuition that you somehow agree that plus into minus is minus, isn't it? I've relied on that. But we know that plus into minus is a minus in the case of numbers. How do I know that it works out over here as well? Correct? Now, let's look at this picture again. Or let me draw another picture for you. Oh, how about we use it over here? Can you find A minus B in this case? Just to follow the rule blindly, we'll see what we get now. Can you find A minus B? So A minus B is what we're doing, right? First, what is the first step over here? What is the first step? Yes, Yashwardhan, what is the first step over here? What do we do? Yashwardhan, are you speaking? I can't hear you. Nehal, what is the first step? What do we do here? Just need to join points. Okay. First step would be to flip the vector b, isn't it? We want minus b, so let's flip that vector b. So vector b, look how it's going. So it's going from 3 to 3 2. So that is vector representation of vector b. So let me do that over here. 3 2. But in the opposite direction. I'm going 3 2, but in the opposite direction. You see. So in the case of B, I was going 3 steps to the east direction and 2 steps to the north. But in the case of negative B, I'm doing exactly opposite. I'm going 3 steps backward, 3 steps to the west and 2 steps to the south. That is B vector. All right. Sorry, negative B vector. If B vector is equal to 3 2, then negative B vector, look at that, what happens here. Negative B vector, it's as though I'm multiplying the negative sign to both the two things there, both the components. So negative B vector is negative 3, negative 2. Agreed? So let me add A vector and B vector now. Sorry, negative B vector. So I'm going to copy this vector over here. So negative B vector is negative 3, negative 2. So negative 3 steps. Yeah, this is where you end up. This is negative B. Now add according to the triangular law the A and negative B vectors. So when I add them, what do I get? I get A minus B. What is the representation of A minus B, by the way? What is the representation of A minus B? Just look at the picture over here. What does it look like? This is A minus B. What is the representation of that? A minus B is negative 4, 1, isn't it? That is A minus B. So it is as good as saying, let's see, A vector representation is negative 1, 3. This is A vector. See, negative 1 and 3. That is A vector. And negative B vector, or let's say B vector is 3, 2. B vector is 3, 2. So A minus B, it is just like we subtract the components. Look at that. Minus 1, minus 3 is minus 4. And 3 minus 2 is 1. So negative 4, 1. Look at that. So whatever algebra that you do, whatever numbers that you write down, you will have the proper picture there. You can either do it by pictorial methods or by algebra. Okay. Yes. Let me go forward now. What about B minus A? What about B minus A? Can you do B minus A? Is it same as A minus B, by the way? Is B minus A same as A minus B? In
No,
the case
sir.
of no, in the case of numbers, definitely not, isn't it? 1 minus 2 is not same as 2 minus 1. In the case of arrows, let's see, is it the same? A minus B and B minus A. So I'm not going to wait for you. I know that you know how to do this now. So B minus A. So minus A, let me plot that over here. So A is basically one step to the west and 3 steps to the north. So negative A would be 1 step to the east and 3 steps downward, southward. So 1 step to the east and 3 steps downward. This is negative A. Correct? So B minus A, just to join the tail of B vector to the head of A, negative A vector. This is B minus A. What do you observe the pattern here, A minus B and B minus A? There is some pattern to be observed, no? Let me draw that A
They're
minus.
opposites.
They are opposites, right? Yeah, correct. So let me draw the minus B vector over here. Minus B would be something like this. Okay, you cannot see this. I'm just doing the previous problem again. So this is negative B. A minus B was like this. This was A minus B. So look at B minus A. Look at B minus A. It's same. It has the same size. It has the same size, but it is opposite in direction. Look at that. So basically, if I take A minus B, what is A minus B? A minus B is this vector over here, this one, A minus B, and see what its opposite is. What is the opposite of A minus B? Just multiply by negative sign, isn't it? That's what we do. I just flip the vector. So what happens over here? This is minus A. This becomes minus A. Minus into minus supposed to be plus B vector. So now I know the commutative property is valid, isn't it? In the case of vectors, you can add A plus B and B plus A. They are both the same things, isn't it? So I can commute these things. So I'll get B minus A. So what I'm saying is the opposite of A minus B is B minus A. You can see it pictorially also over here. All right. Sarvesh, did you get your answer over here somehow? How did we know that A minus B, that step is proper? Because if you look at these vectors, they behave just like the numbers, isn't it? So if you had taken A minus B numbers, 2 minus 1, and multiplied both the numbers by negative 1, what would you get? 1 minus 2, isn't it? Yeah, they behave just like numbers. So that's how I know that I can take the sign that I can write that A minus B as A plus into minus B. I can write A minus B as A plus minus B, because they behave just like numbers. All right, even though they are arrows, they behave just like numbers. There is one more answer that I could give you, but I'm afraid I'll end up confusing you, but I'll try it anyway. Okay, so suppose I take the A vector. This is my A vector. Okay, and let's say B vector is something like this. Here's B vector. What is A minus B now? A minus B would be, I have to flip the B vector and add it, isn't it? This is the rule that I gave you. So I claim right now, this is just a claim now. Okay, let's not claim anything. Let's say this is some C vector. Let's say that is some C vector. This is C vector. Okay. Now I'm going to draw you B vector. Look at that. B vector would be a vector that starts over there and ends over here, isn't it? Do you agree? This is B vector. It is opposite of negative B vector, correct? That's what we say negative B vector is, right? Now what is C vector plus B vector? What is C vector? Look at that. C vector. What is C vector plus B vector? C vector plus B vector. Can you just look at that picture there? C vector plus B vector. What does it give you?
A vector?
Yes. The C vector, we do not know what that C vector is, But whatever that C vector is, when we add that to the B vector, we get the A vector. Do you agree? Now, what kind of vectors have that property? What vector would have that property? C vector, when added to B vector, we get A vector, right? What must be C vector?
Displacement.
No, it can be any vectors. C vector. These can be forces. These can be velocities, displacements, whatever. Look at that. So C vector has to be equal to A minus B vector, isn't it? Look at that. You can take it to the other side, right? I told you I do not know what the C vector is, but the C vector has the property that when I add that to the B vector, I get the A vector, right? So C vector has to be equal to A minus B. See, look at that equation again. A minus B plus B is equal to A, isn't it? Because B and B would get cancelled there, right? B and B would get cancelled, and that C vector has to be equal to A minus B. So I said I do not know what this is, but it seems like it is. It has no other choice but to be A minus B vector. Okay. Are you convinced that now this property, this particular thing works, where you flip the A vector, sorry, you flip the B vector and add it to the A vector, you'll get A minus B vector. All right, that method works. You'll see several proofs of that. Okay. So we have seen this. A minus B is negative B minus B, isn't it? Yes. How to do this directly? What do I mean by directly? Now, before in the previous method, I had to flip the B vector, isn't it? I had to flip the B vector and do all the. Without flipping, how would you do it? Without flipping, can you do that? I just gave you the clue in the previous problem. I just gave you the clue in the previous problem. Without flipping, can you just move the B vector there and can you do this problem? Can you think of a way using the triangular law itself? You have to find A minus B vector. No flipping. No flipping allowed. You can move the B vector, of course. Now it's a puzzle.
So you
Yes.
can just move the A vector, right?
Yeah, you can move the vectors, but just no changing the sign. No change in the direction, that's all. You're free to move the B vector, you're free to move the A vector, but don't flip the vectors, that's all. How would you find A minus B? Clue was given in the previous problem. I had done something there. I told I messed up.
So bring the head of the A to the tip of B.
Bring the head of the A vector to the tip of the
B vector.
then what would you have? Let me draw that for you. So bring the head of the A vector. Okay, so A vector.
No, sir, it won't work. It's like some other figure only.
Yeah.
So remove the tail of the B vector to join the tail of A vector.
Join the tail of the A vector to the tail of the B vector, right? That's what you're saying.
Yes, sir.
So 3, 2. B vector is 3, 2. So let me do that over here. This is B vector. Then what should I do?
Sir, and then from the head of A to the head of B.
Okay, let's see. So from the head of A vector to the head of
B vector.
okay, this
And
is
that vector will be the same. Well, yeah, okay.
okay. Why?
It's,
Let's call this. Let's say that we do not know what that is. That is some C. That is some C. Now, are you sure this is A? This C is nothing but A minus B.
So should we change the signs? Like if we
No,
do this,
we are
method,
not
we'll
allowed.
have to
We are not
change-
allowed to flip the vectors now. We are not allowed to flip the vectors. Avni has given me an answer. Can somebody confirm or deny that this is the right answer? What do you think, Nidhishri? Is this correct?
I think it is, but I'm not sure.
sir, I
You-
think the arrowhead should be at should be connected to A.
Arrow edge should be connected to A, is it?
Yes, yeah.
Okay, let's do that. So arrow edge should be connected to A. So this you claim is A minus B. Nidhishri, what do you think? She has changed her opinion now. What do you think?
Sir, I didn't hear you.
Is this correct, Nidhishri? Is this the way
I
to do?
think, sir.
You?
I think it is correct.
Okay. You think it is correct? Let's see. So easiest way to verify is just do the algebra. One second. Okay. So what do we have over here? We have B vector plus C vector. What is B plus C vector here in this picture? In the picture given by Avni, what is B plus C vector? That's A vector, isn't it? That's A vector. What I'm interested in whether is to verify whether C vector is actually equal to A minus B vector. Let's see. So if I'm right, if Avni is right, that if this C vector is equal to A minus B vector, then the left hand side and the right hand side should match, isn't it? Do they match? So B plus minus B, okay, they get cancelled, and what remains is A vector. Yes, correct. So the left hand side matches with the right hand side. So this is A minus B vector. What does B minus A vector look like? Avni, the same question goes to you. What is the B minus A vector? This
Right.
is A minus B. What is B minus A?
Write the opposite, which means the arrow direction will be on the other side.
Yeah, so all we have to do is change the direction, because we have already shown that A minus B and B minus A are opposite, isn't it? So we just have to flip the vector there. So this is B minus A. Okay, you can verify that. A plus B minus A is equal to B. Look at that, it works out. So this is the way to add, this is the way to subtract two vectors. Okay, this you can take as a way to subtract vectors. So just keep the tails, just match the tails, and then you figure out which way to draw the vectors. All right, you know how to get the directions right, isn't it? The next important operation, we have learned about how to add vectors and how to subtract vectors. The next concept is how to scale vectors. Scaling means what? What do I mean by scaling? It's right there. Scalar multiplication. Scalar is what? Scalar is basically a number, isn't it? So scaling, when I say scaling, I mean you take the vector A, if you are given a vector A, and you multiply by 2. Look at that. I want to find 2 times A. So what is 2 times A? 2 times A is basically A plus A. Agreed? So that's what we want, isn't it? A plus A. If you take 2 A's, A plus A is what? 2A. So 2A is a vector. 2A is a vector that is obtained by just doubling the length of A. Just double the length of A, you'll get 2A. You can think of this as A plus A. Look at that. This is A plus A. So you'll get 2A. Okay. What about negative 2A? Negative 2A. Just flip 2A, isn't it? Same thing works. You get 2A first, then flip it. So that would be negative 2A. Okay. Now comes the puzzle. Here's the puzzle for you. All right. The puzzle is this. You have to write A vector, the capital A vector, in terms of small a vector and J vector. You know the J vector, right? J vector is basically 0, 1. So you have to write capital A vector in terms of small a vector and J vector. What do you mean by writing a big vector in terms of other vectors? Let me go back to this. So I taught you that if I give you any vector, like this, let's say this is A vector, you can write this A vector as what? You can write this A vector as 3 times I vector. What does 3 times I vector mean? I vector is this vector. 3 times I would be the same vector but has 3 times the magnitude, isn't it? 3 times I vector plus 2 times J vector. Look at that. So basically we are writing this A vector as 3 times I vector plus 2 times J vector. J cap, we say J cap. Do you agree? This was easy to do, isn't it? So if I give you, let's just take an example over here. Can you express this vector? Can you express this vector in terms of I and J? Let me tell you what is I and J. This is I, can't see. This is I and this is J. Can you write in terms of I and J that particular vector? I don't even know, I've not planned it. That particular vector in terms of I and J. 1 second. Yeah, looks correct, yes. Sandra is correct here. So basically, how many I vectors and how many J vectors do you need to make up that A vector? Neha is correct. So let me do this one. Sarvesh is correct. Nilsri, yes. 7I and how many J vectors? So 7I, you are right. We need 7 of I vectors. 7I and 6 J vectors. So 7I plus 6J, you add this vectorially, you get, vectorially meaning according to the triangular law, you will get the A vector, right? Now, I'm asking you to do the same thing in this case, but here we do not have, I vector and J vector. I do not have I and J vector. I have A and J. I've told you what A vector is, small a I mean, and then I have J vector there. So how many A vectors do you need and how many J vectors do you need to make up that A vector? All right, that's the question. Just have to draw this out. Yeah, Rohit, what to do over here? Can you help me out? Rohit, there are 2 Rohits. Yes, Rohit Jayvital. Yes, I'm sorry, I cannot pronounce it.
Yes, sir.
Yes, Rohit. Are you on a mobile device or something?
Yeah.
Okay. One second, I'm sorry. Got that my video is off. Rohit, you'll have to keep the mic on, okay? Because your voice is breaking. Yes. Yes, Rohit, what to do over here?
I think the J vector is 2, but
Okay.
no idea about it.
No idea about the A vector. Let's do this algebraically. Can you tell me the representation of the capital A vector? How do I write this capital A vector? In terms of I and J vector, how many I and J's would we require?
5A and 2 J's.
How many is that? Yeah, let's see. So we require 5 I's, right? We require 5 I's and 2 J's, correct?
Yes, sir.
Agree with that? But what is small a vector? Look at that. What is small a vector? Do you look at it?
1 comma 1.
Yeah, 1 comma 1, but it is also 1 I and 1 J, correct?
Yes.
1 I and 1 J. Now let's look at it, Rohit. So I want a vector, capital A vector, which is nothing but 5I plus 2J, correct? 5I plus 2J, right? But I have to write it in terms of small a vector and small j vector, correct?
Yes, sir.
So first of all, what I need is 5I. Now 5I cannot come from here, right? This is purely j. Look at that. This is j only, right? So where can I get the 5I from? What's the only place that I can get the 5I from? A vector.
Small
So
a.
yeah. So how many A vectors do I need? How
Mm,
many A vectors do I need?
5.
5. Correct. Very good. So I need 5 A vectors. But if I take 5 vectors, there's a problem. I am also taking 5 J vectors, isn't it?
Yes, sir.
So what should I do? I should subtract out the J vectors, isn't it? Now I have 5 J vectors. How many J vectors do I need to remove from this?
5.
No. I have 5 J vectors. I want only 2 J vectors, isn't it?
Yeah.
Yeah. So how many J vectors do I need to remove?
3.
So A comes out to be 5A minus 3J. 5A minus 3J. Now this is the way I think about this. All right. You could also, Avni, how have you done the problem? I see that you are the first one to give me the answer. How did you do this particular problem? What did you do?
Sir, I didn't get an answer.
Oh, that was Neha. Sorry. Neha, sorry, you are the first one. I gave great problem. Yeah. Neha,
Sir, I just used the figure.
you just use the,
Figure.
okay, you just drew it out, isn't it?
Yeah.
Let's see. So I want A vector here, capital A vector. I want capital A vector. So let me use the small a vectors. So what is small a vector? Small a vector is this, isn't it?
Yes. Sir.
So I have to go only in that direction, right? I cannot change my direction here. Am I doing it right? 1 second. Yeah. How many a vectors have I obtained now? Look at that.
5.
5, right? Why did I drew till there? Because if I go too far, then I can't get to A. Look at that. I have to get back to this A, right? I have to get here. So I drew 5 of them because I basically wanted to get to this point. Now, once I've gotten to that point, I can use this J vector to come down, isn't it? Look at that. This is 5A vector. This is 5A vector. And from that point, I need to get down. By how many steps do I need to get down? 2 steps.
It should be 3.
Sorry?
It should be 3 steps down.
It should be 3 steps down, isn't it? Have I made a mistake? 1 second. Yeah, it should be 3 steps down. Here I'm getting a different answer. 1 second. Let me check this.
So in the vector that you've drawn, that 5A vectors, it was only 4J when you drew it up.
Okay. So let's see. I did not draw the 5A vector. See, this, that was my mistake. This is 1A vector. This is 2A vectors, 3A vectors, 4A vectors, and 5A vectors. Yeah. Now it is proper, isn't it? I think I missed the direction a little bit. So this is 5A vectors. And from here, I need to get 3 steps down. Yeah, now it's looking proper. So negative 3J. This is the negative 3J vector. Because this is negative J, this would be J. Right? So we get 5A minus 3J. Yashwardhan has given me 2A 2A plus 3J. Is it Yashwardhan? What are you trying to say? 2A. Okay, you messed up. Okay, it cannot be correct. See, 2A would be this. This is 2A. I'm sorry. This would be 2A.
Sir,
Yeah.
I'm Aisha. Sir, I can leave.
Yes. Sure.
Thank you, sir. Thank you, sir.
So 2A plus 3J won't work. 2A plus 3A, no, that's against the rules. That's against the rules because, yeah, 2A plus 3I would work. Look at that. 2A plus 3I would work, but I asked you to write in terms of A and J, isn't it? So you can do that. 2A plus 3I also gives you the A vector. Okay, but you are breaking the rule now. Both of them are same things. Because A is what, like I said, A is nothing but I plus J. A is nothing but I plus S. See, look at that. This is I plus J. So 2A means 2I plus 2J. So I have 2I and 2J. Look at that. So 2I plus 2J plus 3I, that will give you 5I. 5I plus 2J, that would work out, isn't it? It's the same thing as before. We'll see where this becomes useful. Right now it is just in this crude form. It looks like we are solving puzzles right now. How do these things help in the problems we'll have to see? Okay, try this out. Again, the rule is this. You have to write A vector, capital A vector, in terms of small a and capital J. But J is different now. This is not J cap. Let's call this as some J vector. I should not have used the letter J there. Look at what J is. It is -1, 1. Okay, here you'll have to scratch your brains a little. Rohit, this question is still for you, okay?
Yes, sir.
Yeah. Nihal, no. Small mistake, Nihal. Just to see again, just check again. By the way, you have to write capital A in terms of small a and j. I think you have done the other way around. Have you? How many small a's do you require? And how many j's do you require to make capital A? Here, instead of doing the problem, staring at the screen would be allowed. Okay, just keep staring until you get it. I would actually prefer that. That you just stare at the screen and get the answer. If not getting it, stare for a longer time. That's it. Rohit, are you staring? The webcam is off, Rohit.
Yes, I am.
Yes, sir, I am staring.
Okay, both of you. Okay. Did history any enlightenment?
Yes, sir.
Okay. Did you say yes, there is an enlightenment, or you just asking me? Did you get it in the history?
So I didn't hear you.
Oh my god.
I just heard my name being called.
So, did you get the answer?
No, sir. It's kind of confusing.
Okay, good. It is supposed to be confusing. Sarvesh, is it? Sarvesh, are you writing it the other way around? Because I see capital A there.
Like, sorry, sir, small a, not capital.
Okay, then no. Just look at it again. If you have capital 2, sorry, 2 times A, this would be a very long vector, right? Look at that. So how will you ever get to this point? Can you get a short vector like this? If you have 2 A vectors and 2 J vectors, can you have that vector there? Is it possible? Does it look like it will work?
No, sir.
Yeah. So you have to rethink your strategy now.
So, but that the one which I wrote, that would work for small a, right? I actually placed the vectors above each other, so I just guessed the answer.
Okay. So you are saying actually, yeah, that would work. Yeah, good. So 2 times capital A. So what Sarvesh has done is the other way around.
I just put it, yes, sir, that way. I've put it one upon each other and then tried.
Yeah, this is 2 times A. Then I have J vector there, right? I have J vector. But I have to get from this point to that point. So J vector is basically a vector that goes 1 step to the west and 1 step to the north. Right? So I need to go 1 step to the east and 1 step to the south. So that would be negative J vector. This is negative J vector here. And if I have 2 of these negative J vectors, then my job is done. I get small a. Okay. Yashwardhan, yes, you are right. Yashwardhan, you are right. Now you go backward from here. See? Now you do the algebra. So if you figured this out, so a vector, small a vector is capital 2 a vector minus 2j vector, isn't it? Right? Now I've told you these vectors, we have so far our observation has been this. Vectors behave just like numbers, isn't it? Vectors behave just like numbers. So I can add both the sides by 2j now. Let me add 2j on both the sides. So what would happen? On this side, this 2j would get cancelled, isn't it? That's what we have observed so far. This has been this has been our experience with vectors. Now I want a vector. I want a vector, capital A vector, I mean. So what I'll do is I'll do a multiply throughout by half. So what will I get? 1 by 2 a vector, small a vector, plus j vector. Okay. Now how to know whether this is correct or not? This is algebra, isn't it? How do I know that this is correct or wrong? Draw it out. Draw that exact thing out. Okay. So that's how you can verify your answers in vectors chapter. So you can just draw it out. So draw half a. What is half a?
2 by 1. Like 2 comma 1.
Okay. Yeah, correct. So half a is this. Just make half of this. Just get the half of that. So half A would be this vector here. That is half A. Right? So let me just draw that out. So this is half A. And a full J vector. Sorry, this is not J cap. I'm sorry. This is J vector. A full J vector. So what is a full J vector? A J vector is basically one step to the west and one step to the north. So one step to the west and one step to the north. So you can see that my simplification, algebraic simplification, and my diagram over here are exactly the same. Look at that. You get that answer, right? You get the exact same answer. So I think by now you're convinced that vectors, these arrows, the way they work is just like numbers. But an additional point about vectors is whatever algebra that you do, whatever that you write down, you can draw it out as well. So you can see for yourself by drawing things out whether your answers are correct or not. All right. Okay, now begin the problems. So what was I doing until now, right? If the problems begin now. What is the sum in unit vector notation? I hope you know what unit vector notation is. Unit vectors are I and J vectors. What is the sum of sum in unit vector notation of the two vectors 5i plus 3j? First you draw that out, and b is equal to negative 3i plus j. What is the magnitude of the vector a plus b? You know what a plus b is, right? And according to the triangular law. Remember how to find magnitudes?
Excuse me, sir.
Yes, Sarvesh.
So, like you said that vectors act like numbers, right?
Yeah, they behave. Yeah, that's what we have observed so far. Yes, Sarvesh.
So then, why don't we directly just add 5i plus 3j with minus 3i plus j? We would get the answer as 2i like plus 4j.
You're right. Draw it out and see. Confirm it. Yes, Sandra. Yeah, that's what I meant when I said they behave like numbers. Now you draw it out and see whether the answer is correct or not. Yes, yes, Shwardhan. Good. In the previous class, I told you that I'll give you the slides now. I hope you're reading the textbook as well. Seen that yellow colored book, that one? So there are many exercises over there. You just try them out. So 5i plus 3j, what does that look like? A representation of that would be simply 5, 3. A is nothing but 5, 3, and B is nothing but negative 3, 1. So this is A and this is B. You can put them like that. So 5, 3. 1, 2, 3, 4, 5, and 3. Did I get it right? One second, let me have a thicker one. This is A. This is 5i plus 3j. Is it correct? Just count the steps there. 5i plus 3j. And B is negative 3 and 1. So negative 3. So negative 3, 1. So go 3 steps back. Go 3 steps back. And go 1 step up. So this is B vector. 3 steps back and 1 step up. Does it make sense why it is behaving like this? Look at that, the way I'm saying it also. 3 steps back. See, first, what is A vector? You're starting from this location. Yeah, let's think of these as displacement vectors. Okay, what is wrong? So you're going 5 steps to the right. You're going 5 steps to the right and 3 steps up. That is A vector. That is the first displacement, isn't it? And then what do? You walk 3 steps back. You walk 5 steps forward. Then you're walking 3 steps backward. What is the net displacement? What is the net displacement along the x direction? 2 steps, isn't it? It's like you walk 2 steps. And then what you do is you walk 3, look at that, a total of 3 steps up. And then you walk again a total of 1 step up. So how many steps have you walked upwards? 4 steps, right? So that's what we are basically doing when you are adding vectors. That's what we're doing. We are looking at how many steps we have walked along the horizontal. So we say that, okay, we have walked 5 steps forward, but we went 3 steps backward. So how many steps have we gone forward? We have gone 2 steps forward, a total of 2 steps, right? And 1 second. And then we go 3 steps up and 1 step up again. So that is a total of 4 steps up. So 3 steps up and 1 step up. Total of 4 steps up. Correct? So this is kind of an obvious thing. It's just a big name, vectors, isn't it? It's an obvious thing. So now you can look at this picture now. So this is basically, yeah, this would be the A plus B vector. Here you can see that it is 2 steps to the right and 4 steps up. Okay, what is the magnitude of the vector A plus B? What is the magnitude? What do I mean by magnitude? The length of the vector. How do I find the length of this vector? How to find the length of the vector? Remember anything called
Pythagoras theorem.
yes, Pythagoras theorem, right? See, we have formed a right angle triangle. We can form a right angle triangle. Look, we've got a right angle triangle there with sides 2 and 4. Sides 2 and 4. Yeshwardhan, length cannot be 4. Length cannot be 4 because look at that. This length itself is 4, isn't it? So isn't this length a little bit longer than this length? Can't you see? Look at that. This length is 4. So you can clearly see that this length is a little bit longer than that length. So it has to be slightly longer than 4. Cannot be 4. It has to be longer than that. So let's find the length of A plus B.
Sir, root 20.
Root 20 is it? Okay. Root 20 is it longer than 4? Sorry?
Yes, sir. It's 4.47.
4.47 is it? Yes. Makes sense. We have predicted that it should be slightly longer here. So 4.47 is. So what is wrong? So A plus B, how do I write this? Look at this new notation now. Length of A plus B, we write these columns there. So new symbol, that's all. So whenever you see the symbol, if I write this length of A vector, see, when I write these 2 columns there, I mean length of the A vector. This would mean length of the B vector. So this stands for length of A plus B vector. A plus B vector is over here. You have to find the length of that. So this is nothing but square root of 4 square plus 2 square. Pythagoras theorem. So 4 square is 16 plus 2 square is 4. This will come out to be root of 20 units. The root of 20 units, which I think Rohit told us is around 4.6. 2 vectors are given by A is equal to 4i plus 3j plus k and B is equal to I plus j plus 4k. Find A plus B. What is k now? I've never spoken about this k. No? What could it be? What could it be? K?
Constant.
No. Why it cannot be a constant? Why can't it be a constant?
Because it'll have no value if it is a constant. Like there is
Constant is a value, no?
But certain vectors it won't have any meaning, right? Like
Yes, correct.
4 minus 3j and then a constant. What does that
Yeah,
mean?
correct. So 4i, very good, Saroj. 4i minus 3j would be a vector. It's got a length and got a direction. And if it just k is just a constant, it's like adding, okay, to this arrow you add the number 2. Can you do that? 2 arrows, can you add numbers? No. Arrows, basically vector means arrows, isn't it? Can you add numbers to the arrows? No. So vectors can be added to vectors, right? So whatever that k is, it should be a vector as well. Okay. Now k, see I, j, k kind of makes sense, isn't it? I is a unit vector along the x direction. J is a unit vector along the y direction. Can you take a guess now? K is a unit vector along the z direction. Okay. So now we are going in 3D space. We are walking 4 steps forward, -3 steps downward. We are walking 3 steps downward, and then we are going outward by 1 step. You're walking in the room, all right, where you are allowed to walk up and down as well. Now the rules of the game are still the same. Just because I added a new thing over here, they do not change. Same thing. All right, 4i minus 3j plus k, and b is equal to that. Find a plus b.
So just because a dimension is added, it will still work as this thing. Right?
Exactly.
It'll still
Exactly.
be a number.
It still no, not number. It would still work like the previous.
Work like a number. Yes, sir.
The previous rule would still be applied, because z direction is not a special direction. You see, is it like special like x, y, and what's so special about z direction? Nothing. So exact same rules should apply, isn't it? It's just that I won't be able to draw it out for you. I would have shown it to you, but I can't draw these arrows because they are coming out as well, isn't it? The previous arrows were flat on the surface, on the screen. Now this arrow would be coming up by 1 step. So if you want an imagination for this, a vector. So how do you imagine a vector? So a vector is, let's see, 4i minus 3j. So 4i minus 3j, that is this. This is 4i, correct? This is 4i minus 3j, that is 3 steps down. So this vector over here is 4i minus 3j. This is 4i minus 3j. What does plus k mean? So 4i minus 3j plus k means what? You have to go upward, right? How many steps? 1 step. So just imagine.
So, but in a Cartesian plane, we can't make it upwards, right? It's too.
In a plane, we can't. In any plane, we can't. Right? So here, you have to come 1 step up like this, and the arrow, the same arrow, just raise it a little bit. That will give you the idea as to what a vector looks like. So to 4i minus 3j, you add 1 vector, that 1 step up. By up, I don't mean this way. This is not up anymore. Along the z direction. So that would be your a vector.
So like in this C sub question, it's right. Vector C. So like should we find the like such that a minus b plus c equals to 0? So
Yeah.
should we find the answer of negative a plus b? Like
negative a plus b. Why?
Yes, sir. Because it's variables. No, it acts like here if we a minus b plus c equals to 0, so c equals to minus a plus b.
Correct. Very good. Yes, exactly. So basically, you have to find what? Just move it around. Just move that around. So basically, you have to find c is nothing but b minus a. They're just adjusting over here. Look, a minus b is already what we've got. C must be equal to b minus a, because b and b will want to get cancelled, and a should get cancelled, so that we have 0. Nothing left. Correct? That is as good as saying Sarvesh taking to the other side, isn't it? You'll get the same answer, b minus a. So a plus b. What is a plus b? Just imagine you're walking 4 steps to the right. Then you're walking 1 step back. Look at that. 4 steps forward, 1 step back. A total of how many steps forward is that? A plus b. How many steps forward is that? That is 3 steps forward, isn't it? 3i. I means forward. Okay. Then we have walked 3 steps down. Okay, I can't sit down here, along the vertical. 3 steps down the vertical, and 4 steps along the, sorry, not 4 steps, 1 step up, isn't it? So total of how many steps do we have there? Negative 2j. So we are still down. And k plus 4k, what is that? That is 5k. So this is a plus b. In this particular form, this would be 4 minus 3 1 plus minus 1 1 4. Just add them. 4 minus 1 is 3. Minus 3 plus 1 is negative 2, and 1 plus 4 is 5. So you're getting the same thing. What about a minus b? Yes, Avni, correct. What about a minus b? Yes, Avni, correct. What about the last one? Sriniket, can you help me out over here in the second case? Yes, Sriniket, is it there?
Sir, I am there, sir.
Sorry?
Sir, I am here, sir.
Yeah. Okay. Can you help me out? What is A minus B? A minus B, Sriniket. This is just subtraction, but three different subtractions. Look at that. So basically, so this is the sad part now. Basically, I'm teaching you subtraction again, which I've already learned in your third or fourth. Look at that. So basically, A minus B means this: 4 minus 1, 4 minus of minus 1, 4 minus of minus 1. What is that? See, we are doing this: A minus B. So subtract the x component of A, sorry, the x component of B from the x component of A. That is 4 minus of minus 1, isn't it? So what do we get there? We get 5. Then we have minus 3 minus of minus 1. Avni, have you made a mistake there? Minus 3 minus of minus 1. That would be minus 2. And then we have k minus 4k, that is minus 3k. Yes, Avni, correct, no?
Sir, I
is it
might have made a
minus
mistake. I'm
J
not
or-
sure.
Yes, Rohit, sorry.
Is it minus J or plus? Like last time we did it as plus J.
1 second.
Can you erase that red color? Yeah, it's plus.
Oh, sorry. Yeah, Avni. It's proper. I was just checking you, okay? Yes. So this is minus 3j minus j, which is minus 4j. Yes. So that is A minus B, and C. Service has already given us input there. C has to be equal to B minus C. C has to be equal to B minus C, isn't it? Now that's simple. If I know A minus B, I can know B minus C as well. All I have to do is flip the signs, isn't it? Go on flipping the signs. Because A minus B and B minus A, we have seen that already. B minus A, if you take the negative sign of that, if you multiply by the negative number, you get the answer. So C is equal to B minus A. Or you can do it directly. Minus 1 minus 4, that is minus 5, which is as good as multiplying by this by negative sign there, minus 1. And then you would have plus 4j, because it is j minus of minus 3, sorry, 1 minus of minus 3, which is 4, and 4k minus k, that is 3k, it is plus 3k. You row a boat perpendicular to the shore of a river that flows at 3 meters per second. The velocity of your boat is 4 meters per second relative to the water. Oh my god, big words. What is the velocity of your boat relative to the shore?
This was the same example you gave, but there was no value that time. So yes,
Okay. Yeah. It looks tough because now there is like a lot of big words there, isn't it? It's like you're going to those fancy restaurants. So there they describe poa. What is that? Beaten rice with the spices and the coriander and dash of coconut and a little bit of olive oil, and basically they're describing the poa, right? So this is exactly like that.
Sir, is the velocity 1 meter per second?
No.
Sir, is it 5?
Yes. What is the velocity of your boat relative to the shore? But make sure you understand the question also. You understand the recipe of the poa here. Okay, what exactly is happening? Yes. So we have, for some strange reason, I'll be drawing the river as these two lines. Okay. Now you row a boat perpendicular to the shore. So this is the shore. This is shore A and this is shore B. So you're rowing the boat perpendicular to the shore. So here's the boat. Okay, so if you want me to give some shape to this boat, this is what it looks like here. That's the boat. And you row it perpendicular to the shore of a river that flows 3 meters per second. So what does that mean, Sandra? The river flows 3 meters per second. What does that mean? What is the meaning of that?
The river is moving in that speed. It's like exerting a type of like a force on the boat, so which
Okay. So
restricts
if I,
the movement.
yeah, correct. So if I put a stick in here, if I put a stick in there, okay, right now it is over here. After 1 second, how far would it have moved from this location? So put a stick there, how far would it move? Stick basically floats on water, right? If the water moves, it takes the stick along with that, isn't it? So if I put something over here, it would move 3 meters in 1 second. Correct? Now that's not something that happens to only the sticks. It happens to the boat also. Boat also moves 3 meters to the right in 1 second. Okay, so that's what this means over here. 3 meters per second. That's the speed of the water. So water drags along with it whatever that is floating on water 3 meters to the right. The velocity of your boat is 4 meters per second relative to the water. What does that mean? So if the boat is over here, in 1 second, it would have moved 4 meters forward perpendicularly. Look at that. The boat would be over here. So this distance will be 4 meters in 1 second. Let me write that 4 meters in every second. But at the same time, what would happen to this boat? Water would take it to the right by 3 meters. So in 1 second, boat would have ended up over here. Okay. So in 1 second, what is the displacement of the boat? What is the displacement of the boat in 1 second? This is the displacement of the boat. You can see it, right? So first displacement, first plus the second displacement in 1 second. So we can find it now. What is the total displacement? So boat was here, now it is over here. So the total displacement is 5 meters in 1 second. 5 meters in 1 second. Is that okay? That's it. Problem solved. So for a person who is on the shore over here, it would appear like the boat is moving 5 meters in that direction every second. Now answer this question. Answer this question. This will be the last question for you. If you want to go straight, now if you want this person to think that you are going straight from shore A to shore B, meaning you want to go straight from A to B, you do not want to drift like that. What should you do? How should you arrange your boat? Can you go straight from A to B like that? What would happen? You will go to the right, isn't it? So if you want to go straight from shore A to shore B, what should be the criteria? What should you do? At what angle should you go? Yes, Rohit?
So
Yeah?
we should go it like opposite, like what we did in the previous problem, like opposite of that.
Opposite meaning we have to go which way? Do we have to go to the right or to the left? What do you think?
Left.
Left, right?
Diagonally
So,
left.
diagonally left. Now your boat can go 4 meters per second, isn't it? Your boat goes 4 meters per second, right? So see, we cannot go anyway 4 meters per second. I cannot go like this. Why? Because the river would bring me back like this, isn't it? Now let's say 1 second. Let me draw a circle over here. So here's my starting point. Supposed to be a circle. Okay, when I want a circle, I do not get a circle.
Excuse me, sir.
Yes.
Sir, in the like just 2 minutes ago, we did the 4 meter, like 3 meter. We did the Pythagorean triplet thing.
Yeah.
Like we found out that if our boat is going straight and if there is a force coming of 3 meters per second, then our plane, like our boat will go diagonally 5 meters, like in the speed of 5 meters per second.
Correct.
Then why not we just turn 5 meters per second to this side, like the other side, and go in that direction? Because if the first equation was right, then we have to come in a straight path where we have to reach.
Yeah, that would have been correct, but the problem is you cannot go at 5 meters per second. your boat cannot go at 5 meters per second because your engine is only capable of driving the boat at 4 meters per second. Let's say that you can't go far, you can't go 5 meters per second. In the first case, what was happening was you were going at 4 meters per second. The river was taking you to the right at 3 meters per second. As a result, you ended up going at 5 meters per second with respect to the person on the shore. Too many words, right? Now what we are doing is 4 meters per second. That's all you can go at. Okay. But now you have to arrange that 4 meters per second. You cannot go 4 meters per second like this. What will happen if you go 4 meters per second like that? Will you reach the other shore?
So we'll be going that the other side itself, because like the other side.
Yeah, correct. Yes, you're right. This is 4 meters per second this way, but river at the same time would drag you back, isn't it? At the speed of 3 meters per second. So your resultant speed would be only this much, 1 meter per second. Does that make sense? So every second it's like you're going 1 meter per second because you're going at 4 meters per second, but the river is bringing you back at 3 meters per second. Just like a drunkard, he walks forward and then falls back, right? So displacement would be small. It would take him a long time to reach home, right?
Excuse me, sir.
Yeah.
So if we actually think of an answer without the velocity, then
Yeah.
shouldn't we increase the weight of the boat and then go to 4 meters per second like speed?
Why?
Because acceleration is in like, I think even wait, velocity is inversely proportional to mass, right? Like
acceleration is inversely. That depends on the force.
yes, sir. So like if the force is 3 meters per second and if we increase
Actually,
the weight, so
yeah.
can't we reach there using 4 meters? Like we can go to the opposite direction of the like from where the water is coming and increase the weight of the boat somehow, like put something there. And from there we can
Actually, it would
reach in a
slow
safe
down.
manner.
No? Actually, it would slow down. If you increase the weight, you would slow down further. You have to decrease the weight.
So better is that we can speed up to 5 meters per second.
But that's the condition, no. See, you cannot solve the problem like you wanted. It's like I can't solve this problem, let me solve my own problem. That won't happen.
But sir, if you decrease the weight, how is it gonna help? Like if you decrease the weight, then
No.
the
You cannot change that. Look at this. Sarvesh, it's been told to you that the boat is going at 4 meters per second. All right. Whatever the weight of the boat doesn't matter over here. Okay. So it is going at 4 meters per second relative to the water. Okay. Now, physically thinking, yes. Okay. I might have to reduce the weight, not increase the weight. You just make the boat heavier and heavier. How do you, with the same motor, how do you go faster? Yes, Sarvesh?
yes, sir, the speed will decrease there.
Speed will decrease, right? Yeah. But we are not allowed to do that actually. It's not like I can't solve this problem, so let me make the boat lighter and let me go at 5. And that problem is easy to solve. That doesn't work like that. So what should I do over here? So you are right. You would have to go slightly to the left. Slightly to the left. But if you go too much to the left, you will not go straight. So this is what we want to do. We want to go straight. Okay. We want to go straight. 4 meters per second is what we can go at. But the river we know is going to pull us back at 3 meters per second, right? You see, I have to go at a proper angle. Now, of course, I cannot find this angle. This would require the next chapter, which I'm going to teach you, trigonometry. All right. So if I go slightly to the right, slightly more to the left, I can't change the length of this arrow. Please understand, I cannot change the length of the arrow because I have to still go at 4 meters per second, isn't it? If I change the length to that, what would that mean? That means I'm going faster or slower. Now, if I go more towards the left, what would happen? This is still 3 meters per second. I cannot change this arrow as well. I'd end up going slightly to the left. Does that make sense? I would go like this. So if I have to go from shore A to shore B in a straight line like that, I'd have to arrange myself in a proper manner, a correct angle that would help me go there. Okay, what that angle is will require a little bit of trigonometry knowledge to figure that out. Okay, do you know trigonometry?
I know only sin A plus cos A equals to tan A.
Oh, that is also wrong. Okay,
Sir,
it is
what's the meaning of trigonometry? I don't know.
trigonometry. Okay, what is the meaning of trigonometry? Trigonometry.
Sir, so 1 minute, sir, before that.
Yeah.
Does this have to do with 30, 60, 90-degree triangles?
30, 60, 90, no.
No? Okay.
30, 60, 90 triangle. What is that? That would be, look at this. If you consider the 30, 60, 90 triangle, so this, let's say, is this doesn't look like 30, but let's say it is 30. This is 60. No, sorry, let me write it the other way around. This is 60, this is 30, and this is 90. Okay, what's so special about this triangle? Oh, I wrote it again the same way. This was supposed to be 60, this was supposed to be 30. What is special about this triangle?
Each angle is the double of it.
Yeah. Okay, this angle is the double of that. Let me complete the picture and ask you the question again. See, I'm making a construction now. I'm making an exact copy of this triangle, but on the right side. An exact copy of the same triangle, but flipped and on the other side. So what would be this angle over here? 60.
60.
And what would this angle be?
30.
30. Now what is special about this triangle?
It's an equilateral triangle.
It is an equilateral triangle, right? So in an equilateral triangle, what do you know? You know that all sides are same. Side, right? And look, get the feel for this. If this entire length is A, this should be A by 2, correct? Half of A. So in the 30, 60, 90 triangle, look at that. This is the 30, 60, 90 triangle, isn't it? What do you notice? What do you notice? The hypotenuse and one of the sides, look at that. They are in the ratio what? 1 by 2. They are in the ratio 1 by 2. Do you see that? This is 1, this is half of that, isn't it? Do we have that over here in this particular triangle? Do we have that property? Do we have 1 by 2? No, right? So hypotenuse is 4. Sorry, what did I do? Hypotenuse is 4. What would this side be from the Pythagorean theorem? Square root of 4 square minus 3 square, isn't it? That is the root of 7. That does not look like a what? 30, 60, 90 triangle, isn't it? See, this, I can tell you something about trigonometry ratios. What is sine theta? Do you remember what I told you about sine theta?
Opposite side by hypotenuse.
Yeah. So let's take this as my theta. If this is theta, sorry, let's not take that. Let's take this as theta. Let's take that as theta. So sine of 30. What is sine of 30? Those of you know trigonometry. What is it?
1 by 2.
1 by 2, right? What does that mean? Opposite side by the hypotenuse are in the ratio 1:2, isn't it? Look at that. A by 2 divided by A. Opposite by hypotenuse is in the ratio 1 by 2. That's what sine means. Okay, sine theta. Okay, if you have a 30, 60, 90 triangle, then you need to have these sides as A by 2 and A. There's no escape from that. So what would this side be? Can you figure out the height here? What is the height? Pythagorean theorem. Root 3 by 2a. Pythagorean theorem. Root 3 by 2. Yes. I'll end the class here. Okay, I've already taken enough of your time. So consider this to be the end of the lesson today. Trigonometry, if you've not understood what I said, perfectly fine, because I'm going to start with the trigonometry basics in the next class. That's the next topic. What would happen if you throw a ball from the light speed ship? Why do you want to do this, Yashwardhan? Why do you want to throw a ball from a ship that is going that fast? If you throw a ball from a speed, See, again, you cannot analyze that problem that easily because you have to use something called as Einstein's velocity addition theorem, velocity addition law. It's not like throwing balls from a bus, all right? It would be fairly complex. So there's something called as Einstein's velocity addition theorem, not theorem, Einstein's velocity addition law. And you would get the speed of the ball to be slightly less than the speed of the light, slightly less. Okay. Oh, not slightly less. One second, I made a mistake. It would be less than the speed of light. Not slightly, by a lot. What was the exact thing that you wanted to ask? Could the ball? No, ball cannot go faster. That's what I'm trying to say. The Einstein's law that I'm talking about is this. It says the speed is equal to the speed of the ball, let's say. The speed of the ball would be, so if there are two objects, let's say, they are moving towards each other. Let's say this is U1, this is U2. In the case of the buses and the car moving together, you know that the speeds get added up, isn't it? If the bus is coming towards you and you're going towards the bus, your speed becomes what? Your speed is more, isn't it? You observe that the speed is more. It appears like the bus is coming towards you faster. Correct, Yashwardhan? Now, in this case, what would happen is, it's not so. Here, the speed of the bus with respect to you would be equal to U1 plus U2. This was the usual case. The speeds would get added up. But in relativity, you would have this as 1 minus U1 into U2 divided by C square. I think there's a square root over here that I forgot. Yeah, now it looks proper. So you'll have to use this law to figure out the speeds. So the ball will not go faster, no matter. You can plug in the values and see. Plug in different values. So even if the ball, even if you talk about the light rays, once again, I think I made a mistake there once. Now I made a mistake in this formula. I can't figure out what the mistake is. Even if you go at the speed of light, then the speed would appear to be c itself. Now this formula is wrong. Just check Einstein's velocity addition. Just check that out. You will see that you get the correct formula. It is of this form, but I've messed it up. That's all. I can't figure out right now what it is. Okay. So when we throw the ball from a car in front of it, let's go fast. Yeah, it does go. So if you throw the ball from the car, the ball would go faster. That's what I'm trying to say. Here, if you throw the ball from the ship, it will not go faster than the speed of light. It will always be slower than the speed of light. That's the law. That's the law. And even Einstein doesn't explain why everything has to go faster. Nothing can go faster than the speed of light. He just says it is. Okay. Because of the experiments that have been done, they did not find anything that can go faster than the speed of light. So if you accept that nothing can go faster than the speed of light, and that is a very hard thing to do, once you accept it, you can see the consequences. Okay, nobody is going to tell you why you cannot go faster than the speed of light. They'll tell you, okay, there is length contraction and time dilation and all those things. But those are the effects of not being able to go faster than the speed of light. Those are the consequences. So length gets contracted, time gets dilated. It would appear that you're taking a longer time and all those things. Okay. But there is no good reason why you cannot go faster than the speed of light. That is the law. That's what we mean by laws of nature, isn't it? It's not that we do not know why it happens. Like inertia. What can you say about inertia? Why do you continue to move in the straight line with the same speed? Why can't you stop? Why do you have to continue moving in a straight line? In space, if you throw something, it will continue to move forever, isn't it? Why? That's the law of inertia. It does. That's what we have observed. We cannot get better than that. That's what we are saying about Einstein's theory as well. It's just like law of inertia. Okay. You'll have to someday make peace with it. Yashwant, I know what exactly you're feeling. That's what.
Sir, could you check the chat?
What chat? You
The
sent me the.
Zoom chat.
I have not received any message here. Second, have you sent it to which account have you sent it to?
Sir,
Sir,
Nidhi
next
sent
class
a
can-
message.
Nidhish sent a message. Sir, next class can I and Avni ask for phone numbers? Ask now only. Whose
Sir,
phone number? do you want?
there's very few people left in the meeting.
Sorry?
There's very few people left in the meeting.
Whose number did you want?
Hopefully everyone's.
Okay, to make a group, is it?
Yeah.
Okay. Okay.
Thank you, sir.
Next class, yes.
Thank you, sir.
Yes. Yes. See you guys in the next class.